Hey y'all, we are starting our next lesson on exponential equations, actually solving them. So this one isn't going to be super long. I really just wanted to recap on some skills you might need in order to get some of the homework done. So just to review what an exponential equation is, it's where we have some function where our input is in the exponent. So the most general form was a times b raised to the power of x, like so. So our input goes into the exponent, we raise a base to that power, multiply it by a, turns out that's our output. So when we made charts, we found out that this was our y-intercept, and then this b value was our multiplier. So this was our, or we called it a growth factor, I think, but basically says every time you increase x by 1, what do you multiply the step before with? So say we had, for example, y equal to 3 times 2 to the power of x, and we wanted to graph that, we could do it just knowing what the multipliers are, what our y-intercept is. So if we were to graph this thing out, let's go out to 2 and then -2. So I'm sure this thing is going to blow up pretty fast. So our x and our y, label this as 2. We're going up by 2's. Okay, so if we were to make our XY chart, well, we know, so let's do -2, -1, 0, 1, and 2. So we know that at 0, we have our y equal to 3. That's just what the y-intercept is telling us. Then we know that our multiplier is telling us, okay, if we increase by 1, we're multiplying this thing by 2. So this guy becomes a 6, and then multiplying by 2 again, we get a 12. So in order to see the other way, we got to think about this backwards. If we went from 6 to 12 by multiplying by 2, to go backwards, or from 2 to 1, we have to divide by 2. We have to divide by 2 again. So if we go upwards like this, from our y-intercept, we're dividing by 2. So that makes this 3/2. And then this one back here, 3/4, dividing by 2. So we get a nice equation. Looks like this. Our y-intercept, that value in front, is right on here. Then we've got a 6 over at 1, and then finally at 2, we're all the way up here at 12. I'll just put it right up here for the time being. So this is actually what our function is going to look like. Okay. So that's what we did last time. We talked about our exponential function, knowing what each part does. So now we're going to go on to solving equations. So one big thing I saw in a lot of the responses on the assessment was this really loose way of using equations and functions. So if we were to actually talk about, or equations and expressions rather. So an equation, you should be always thinking equals. So you're always going to have an equal sign. So an equation relates to expressions or equates to expressions. So for example, something like 3 plus x, that's an expression. It's just some variables, some numbers put together by some arithmetic. 4x would be another example of an expression. But now if we said 3 plus x equals 4x, well then there we have a equation because of that equal sign. So when we're talking about exponential equations, we're talking about setting two equations equal to each other and setting two equations equal, or two expressions equal to each other, excuse me, and seeing what happens, what we need to do to solve for our x. So usually this is more of a simplify case. This one is a solve for x case. So let's do a simple example of solving for x, or solving an exponential equation. We could have 3 raised to the power of x equals 3 to the power of 4, okay? So in this case, we'd say solve for x. What is x? Well, this one should be pretty trivial. You ignore the 3's because they both have the same base, and you say, okay, well, what do I have to replace my x with so that it turns into a 4? Well, we just said it. So in this case, x is equal to 4. Okay? We can check. We check, we plug it in, we get 3 to the 4th equals 3 to the 4th. We are good to go. So our next example gets a little more difficult. In this one, what we're going to do is we're going to look at 2 to the power of 4 is equal to 4 raised to the power of x with different bases. So different bases as in the big number is different. So we're going to have to change one of these numbers so that they're the same base so we can do the same kind of look and see that we did for the first example. So what we need to do is break down our 4 in terms of 2's, follow our power rules, and then ignore our base and look just at the exponents. So we can leave the right or the left side alone, but we know that 4 is equal to 2 squared. So if we remember our power rules, we know that 2 to the 2 to the x is 2 to the power of 2x, okay? So when you have a power raised to a power, multiplying these two powers together. So that's saying that 2x is equal to 4. Or, dividing both sides by 2, x is equal to 2. So we can do a check on this as well. If we do 2 to the 4th, so I'm going to just squeeze the check in right here. 2 to the 4 is just 2 times 2 times 2 times 2, or 2, 4, 8, 16. Now 4 to the x, well, that's 4 squared, or 4 times 4, and we'll see that also equals 16. So 2 to the 4th equals 4 squared. We're good to go. That is a true statement. So another final example we'd have is probably the most complicated one you'll come across for the time being. We could have something like 3 to the x plus 1 is equal to 9, let's say, to the x plus 2. So here you're like, oh my gosh, there's so much going on. What do I do? Well, first off, we want to make sure these bases are the same. So 3 and 9 are different bases. We want to break this 9 down so it comes out to a 3. So again, we can leave our 3 side alone. But we know 9 is just 3 squared. So we can raise that to the x plus 2. Well, here we have 2 times x plus 2, so we have 3 to the x plus 1 is equal to 3 times 2 to the x plus 2. Now that we have the same base, we can start ignoring them, looking just up at the exponents. So x plus 1 is equal to 2 times x plus 2, where x plus 1 is equal to 2x plus 4. And then it's just some algebra. We subtract x from both sides, and we get 1 is equal to x plus 4, and then we subtract 4 from both sides. And we get that x is equal to negative 3. Okay. Finally, again, we can check. And I'll leave that to you, actually. that'll be a good exercise to do. So that's all there really is to solving exponential equations. I hope it helps out with your individual work. And yeah.